Find the derivative of f of t equals 1 over t minus 1 over t squared times t plus 3. Then evaluate f prime of negative 2. F of t is made up of the product of two functions. 1 over t minus 1 over t squared, then times t plus 3. One option is the product rule, but if you can physically take the product, it will often be quicker and simpler. And we can take the product here by FOILing this out. Since we're going to be multiplying with fractions, the t and the 3 you can think of as t over 1 and 3 over 1. Might make the multiplication a little easier. First, 1 over t times t over 1. Multiply numerators. 1 times t is t. Denominators t times 1 is also t. T over t. Outside, 1 over t times 3 over 1. Multiply numerators. 1 times 3 is 3. T times 1 is t for the denominator. And we'll end up with positive 3 over t. Inside, negative 1 over t squared times t over 1. Negative 1 times t is negative t in the numerator. T squared times 1 is t squared in the denominator. Last, negative 1 over t squared times 3 over 1. Negative 1 times 3 is negative 3 in the numerator. T squared times 1 is t squared in the denominator. Two of our terms have t's in the numerator and denominator that can cancel. Our first term is t over t, and those can cancel to leave a 1. Our third term has 1t in the numerator and t squared, or 2 t's in the denominator. We can cancel the 1 from the numerator with one of the t's in the denominator, leaving us with a 1 in the numerator. So now we can rewrite what we have, and f of t is going to be 1 plus 3 over t minus 1 over t minus 3 over t squared. Well, the second and third terms are of the same type. They're both over t, number over t. 3 over t minus 1 over t can be combined together, so we'll have 1 plus 3 minus 1 is a 2 over t, and then minus 3 over t squared. So we now have terms that are added or subtracted, and we can take the derivative of each term individually. The second and third terms have t in the denominator, so we can bring it to the numerator with a negative exponent. So our f of t will be 1 plus 2t to the negative 1, and then minus 3t to the negative 2. It's now ready to take the derivative. F prime of t will equal, the first term is a constant. The derivative of a constant with no t is a 0. The second term is a power rule. Bring down the negative 1, multiply it with the 2. That'll be negative 2. T to the, now subtract 1 from the exponent. Minus 1 is negative 2. The third term, bring the negative 2 down, multiply with the negative 3, which will give us a positive 6. T raised to the negative 2 minus 1 more will become negative 3. A negative exponent means that it can be put into the other position as a positive exponent. So let's take one more step and write each of the terms that way. Negative 2, that won't move, but t is raised to the negative 2, and by being raised to the negative 2, it means it can move to the other position. The denominator is a positive exponent. And plus 6, t to the negative 3, which means that t to the negative 3 can move to the other position. Again, the denominator, the 6 will not move, and it will be over t cubed. There's our derivative. Let's evaluate now f prime of negative 2. F prime of negative 2 means to replace each of the t's with a negative 2. And so I'm going to have a negative 2 over negative 2 squared, which is a 4, and a positive 6 over a negative 2 times negative 2 is positive 4 times 1 more negative 2 is negative 8. Now we can cancel the first fraction by a factor of 2. Take out the 2 and the 4, making it a 2, leaving with a 1. And the second fraction, also by a factor of 2, 6 divisible by 2 gives us a 3, 8 divisible by 2 gives us a 4. There's a negative there, so we will have a negative 1/2 and a negative 3/4. Now the final answer will be a single fraction. These can combine by subtraction. We need a common denominator. We're going to take the negative 1/2 and multiply it by 2/2. The common denominator is going to be a 4. And so we will have a negative 2/4 minus a 3/4. It's over a common denominator now. Negative 2 minus 3 is negative 5/4.